to this talk are lovers of the landscape. And many of you will probably know a good deal about the geology of Shropshire already. But for this talk, I'm going to assume that you don't know a great deal about geology because it isn't a school subject, disgracefully. So many of you will not know even the fundamentals of geology, especially as some of the most important processes in geology have only relatively recently been unraveled and understood, and an awful lot of processes are still unknown and being researched as we speak. So the most important one was only actually, which is plate tectonics, was only derived in the 1970s. So I'm going to explain some of these fundamentals to get started. Now, geology is an extremely slow business. Most mountain building takes millions of years, but some of them are extremely fast, as the world is also very volatile. This is a picture of a representation of the immensity of the time since the Earth was formed. And I won't go into great detail, but I'm sure you're aware that about right to about 30 degrees left is all in the precambrian and is pre-multicellular life. So all the processes of the Earth's crust forming, life developing, which you see started relatively early in the 4.6 billion years of the existence of the Earth. It took an immensely long time for life to become multicellular and complex. And I'm going to start this story at about 700 million years at the end of towards the end of the Precambrian, which, because it's extremely difficult to unravel all these processes at such a long time ago, because the things have been recycled time and time again, we don't really know a great deal, but more is being discovered all the time. And in fact, the Precambrian has now been divided up into a fair number of stages. But anyway, I'm going to just talk about what happened in Shropshire in the last 700 million years. So settle down in your seat, because that's quite a long time, and we'll see how we go. So as I said, most geology happens rather slowly, but some things are. This is the picture. If you've got a camera or a mobile phone, I can't do a handout in this format, but you will probably find it very useful if you've got an image of this to hand. So I'll leave it up for a moment. If you want to try taking a mobile phone picture of this, please do. Or if you've already got this in your house, you probably have. No. All right. So shall we move on then?
Yeah.
Right. Right. Well, I'm sure you're all aware, sometimes geology is not particularly slow. And I did a little interview with Radio Shropshire about exactly 2 weeks ago, just under 2 weeks ago, during which time Iceland was experiencing a lot of earthquakes, huge number of earthquakes on the Reykjanes Peninsula near Reykjavik, which is right on the mid-Atlantic rift. And it was expected that there would be a volcanic eruption, but they also wondered whether the magma that was clearly coming up from the depths might just stop and solidify, and that would be it. Well, astonishingly, about 10 minutes after I stopped my interview, having stated I thought it may not happen, it did. The earth opened up and this wonderful volcano started erupting, just spurting out quite harmless lava as volcanoes go. And it's been doing all sorts of things ever since, causing great excitement in Iceland. And I'd give my right arm to be in Iceland now to go and have a look at it, because it's really exciting and still blowing away. And this cone, I think this was 3 or 4 days ago, the cone's getting bigger and bigger, and it's really assuming the form of a proper volcano now. but it's expected to erupt for a fair while, but not for that long. But there we are, there's a new piece of the Earth's crust developing. Now, the Shropshire Volcanoes, I'm sure you're aware that we host a lot of volcanic rocks in Shropshire. They came up out of the ground many millions of years ago, more like this. They came up along fissures. Nobody's ever found a crater or anywhere on the Wrekin or the Urcle or Cair Caradoc. So it's not exactly understood. And the nature of the rocks in each of these different hills is somewhat different. So we can make some assumptions, but it's likely that originally these came up along the long crack, which goes right through the county, which I'm sure you're aware of, the Stretton fault, even forming the fault, when great stresses were put on the crust of the Earth and split it, and up they came. So there we are, that's in Iceland. Okay, I'm going to start this talk with a bit of a curveball, really. It's supposed to be about Shropshire geology, but I was born and brought up elsewhere in the UK, and I just wonder, a lot of landscapes are immediately clear. You immediately recognize what sort of rock there are underneath, because the hills will form a particular form. And this is one type that, well, it's very familiar to me, and I dare say to some people. You might like to have a guess and dump it on the chat box now. And I'd also like you to see if you know why there's these wonderful ribs along the side of this hill. And I'll give you a good big clue. There's absolutely none of this type of rock in Shropshire. It is completely absent. So when I moved up to Shropshire 15 years ago, the landscape was somewhat alien to me because there weren't any of these rocks. So how are we going to decide what rock makes up a landscape or a hill? Well, you look for obvious exposures, and there's your big clue. I expect a lot of you know where this is. Immediately, this demonstrates that the bedrock is pure white. The pure white limestone, it is indeed chalk, which covers a great deal of southern England, is a sedimentary rock that formed from trillions and trillions of tiny little organisms called coccoliths that settled on the bed of the sea, built up a layer of rock, and eventually it was uplifted. And it's thought that it actually was laid down over Shropshire, because we have chalk right up in Scotland that was trapped by later lavas. But no one has ever found any chalk, or even the remnants of chalk, as far as I'm aware. And so it's now confined to the southeast of Britain in great swathes. So there we are. Now, okay, if you can't find an exposure, it's a good idea to go and look at local buildings, because until the railway age, every village, every town, if they were near hills or exposures, will have their own quarries. And around Wantage, where I was brought up, we had a lot of chalk quarries. And so a lot of the older buildings, and you have to look at old buildings, churches, castles, the like, were built from this rock, which is called clunch, which is the trouble with chalk is it's very porous. It's very poor for building stone. So a lot of the buildings had to have overlapping eaves to stop the rain pouring onto it. And it was often strengthened by flints, which you can see the dark, which are precipitated, dissolved sponges, it is thought. They're quite a mystery for a long time, but that forms a very, very hard silicate rock, which is quite good for building. And I'm sure you know that a lot of buildings are made from flint. And as you hunt around, maybe you'll be lucky and find some fossils if you're of a turn of mind. Even walking around in a field, you might find some of these fossils. These came from a local quarry. The one below came from a quarry near Farringdon, which is very famous for its fossils. Yeah, I can't see the top. All right, also now you go and look for some industry, because man has usually exploited whatever the bedrock is, and often it has built up the bulk of the local industries. And here we have Pitstone Quarry, which is further up the escarpment of chalk from where I was brought up. And it's a very, very pure lime, so it's used in making concrete and other such like. Also, I must say you should have a jolly good look at the soils, because the soils will give you a clue as what the bedrock is. Although always beware, because sometimes you'll find foreign rocks. Well, over most of Britain, you'll often find foreign rocks which have been brought south from the glaciers during the ice ages. So it can be quite misleading. But around here in Shropshire, as I'm sure you all know, we have some very bright red soils, which basically come from the Triassic sandstones that cover the whole of North Shropshire. We have red soils on the Clee Hills, which are old red sandstone. But if you go just a few miles, you'll find that the soils tend to change colour, and they become muds or, different greys. Now, if you're the botanists among you, you must look also at the vegetation, because most plants have a favourite kind of chemistry for their soils. Now, these are quite near us. We live in northwest Shropshire, and these grow, well, the one on the left was growing on Lannamonnock Hill, which is a pure limestone, carboniferous limestone. These are early purple orchids, which grew in great profusion. I've never seen anything like it, just under a year ago at the beginning of lockdown. And the one on the right is a bee orchid, again, which favours limey soils. But if, and these are some of the wonderful verdant meadows, actually on Wenlock Edge, which is another lime stratum. So these verdant with orchids in it, you can be fairly sure that these are going to be limey bedrock here. Okay, so carry on. So if you really are running out of ideas and you've no idea what the rocks are, you have to get a map. And I would get a map anyway. If you haven't got a map, everyone should have a geological map. They're absolutely vital to the understanding of our wonderful geology. And just a brief look at this, you can see these long lines. The chalk here is this light green here, which covers a lot of southern England, but not a trace of it up in Shropshire. You'll also notice that the rocks in Scotland are very much different colours from the rocks in the south of England. And even in the north of England, but I'll talk about that later and you'll understand why. But carry on, Charles. And if you want to buy a geological map, there are plenty on offer. We have our UK North and UK South map in our downstairs toilet, which is an excellent place for it, because I spend many an hour sitting contemplating on my toilet and looking at my geological map and contemplating. On the right, we have the Oswestry 1 to 50,000 map. Unfortunately, the British Geological Society has stopped printing these, which I think is a terrible shame. But you can get an app, and you can get an app which will show you all the geology everywhere, which is actually these maps put on an app. But the difficulty with that is that they don't have an easy way to key into the keys. Yes, yeah. The one at the bottom. Go back, Charles, please. Sorry, my assistant.
Trying to hurry her along, really.
Oh, go away. This is the 1 to 100,000. That shows the whole of Shropshire and quite a lot of mid Wales. And our geology is very, very intimately linked with Wales. So it's a good idea to get the Welsh geology on the same map. Okay, carry on. He wants me to hurry up. Now, the types of rock. Again, this is all very elementary. And if you know it all, go and feed the cat or we'll have a cup of tea or something. but I just think it's worth quickly going through them. The main types of rocks are igneous rocks, which are the primary rocks that come up from below, from the mantle, and solidify at the surface, usually through volcanic eruptions, but often sometimes through rifts, or exposed through erosion, such as Dartmoor and Bodmin Moor. These eroded sedimentary rocks have revealed igneous rocks. Sedimentary rocks comprise most of the rocks in Shropshire. Those are laid down in layers generally. And metamorphic rocks are sedimentary rocks that have been squeezed and heated and changed chemically. We don't have a huge amount about in Shropshire, but we do have them, and more of that later. And also there are many other types of rock, but in Shropshire you will find evaporites. These are rocks that have formed from evaporating shallow seas full of salt. So you get rock salt, but you'll find places in Staffordshire, for instance, where you get alabaster, which is a different kind of evaporite. Some rocks are made almost entirely from fossils. I recently went to Norbury, south of the Shropshire Hills, and the stone walls all around Norbury almost completely made from a shell called a brachiopod shell called Pentamerous. I mean, just trillions of shells all squashed together. And of course, coal is nothing more than altered wood from the Carboniferous era. But there are many other types of rock, but these are the important ones. Carry on. So here we are looking south from Wroxeter at the edge on from our local volcanoes, we'll call them for simplicity, if they're not actually volcanoes. And it struck me, and this is another bit of a curveball, that the Romans built their cities, and I think they chose Wroxeter because it reminded them of other big cities in the Roman Empire. So obviously Pompeii looks at a volcano, or did, before it was thoroughly buried. And Carthage, which I went to 3 or 4 years ago, looks across the bay at some volcanic shaped mountains. I don't think they're actually volcanoes, but they look very similar. And Rome, of course, has its 7 hills, which are all volcanic. And these two, a little bit like our volcanoes. So that's my little curveball. And Wroxeter Church wall was built from robbed building stones, which I thought were basalt. They're not. They're actually hoar edge grits, which are Cambrian rocks coming from the other side of the 7, as you see. Now, the volcanic rocks, and note the shapes of these mountains, very important. One on the left is a thing called a facholith, Corndon Hill. Gentle curves, but quite characteristic of what we call a facholith, which is basically an intrusion underneath sedimentary rocks. It sort of stopped oozing up from the mantle and formed this dome-shaped mountain. On the right, we have the Brecon Hills, which are our local hills. The one on the right is Bryden, which is another facholith intrusion, Ordovician. And this is a dolerite dome, which is sadly being rapidly quarried away as we speak, because it's such a good hard stone. And behind you see Moyle Golver and Middletown Hill, which are rather different. They're more like these fissure volcanoes that we get along the faults. And these are some of the rocks that come from these. That's basalt on the left, and which is rapidly cools and doesn't form anything except the familiar hexagonal columns that you see in Scotland and Stafford and the Giant's Causeway, that's right. And we do have some, but they're just over the border in Wales, in Welshpool. If you look at the quarry in Welshpool, there's some fairly well-formed columns right in the middle of the town. In fact, where the funeral director makes his gravestones. On the right, we have granite, which is another igneous rock. And the difference with granite is that it's it's cooled very, very slowly and has had time for the minerals to separate into three different forms. So the white bits there are quartz and feldspar, another bit, and then there are black flecks, which are mica. And they take many, many forms, the granites, but that's basically, they are slowly cooling. The one in the middle is another from a violent, an andesite from violently exploding volcanoes. And on the right, we have a rhyolite, which is another volcanic rock, which more in a minute. And that's the Criggan rock, which is a very, very hard roadstone, but very pretty, very, very lovely. And it's rather a shame it's turning up everywhere in people's roads just to confuse geologists in the future. Here we have the processes, sedimentation. Top left, very wonderful, what we call conglomerate, formed by eroding mountains in the Devonian era. These are on the coast of Arran Island, where I went on a geology trip last autumn. On the right, these will have formed from eroding mountains carrying sediments down these what we call braided rivers, which start off with enormous power coming down the mountains, but then slows down. They dump the rocks sort of coagulate, and over the millennia they form rocks. At the bottom we have Triassic sandstones, and these, a lot of things were formed in a desert, so they're actually formed from sand dunes, and a lot of it is wind blown, so you get what we call cross bedding. You'll see here that at the bottom line the strata go in different directions. It's likely that they were blown around and then solidified. And at the bottom, ice is another important way of erosion, form erosion. That's the Baltaro Glacier in Pakistan, which is busy eroding, even as the Himalayas are still rising, because they're in a vice between two tectonic plates. They're being eroded and carried down these glaciers and dumped on the plains below. Carry on. And here we are now. We're very close to the River Vyrnwy where we live, and I've canoed down once or twice in summer when the level's very low, and you will see feet of sediment, absolutely astonishing feet of sediments, which is the process of sedimentation happening as we're in our lifetime. This has all come down from the Welsh mountains, carried as a fine mush, basically, and as the river slows or as it floods over, we moan about the floods, but we're constantly having our fields renewed with new sediments, new nutrients. So there we are. And eventually, once the sedimentary rocks harden, we get things like the Silurian fossiliferous limestones of Wenlock Edge, see, all in lines. And at the bottom, this is what we call a turbidite. A lot of our stones in Shropshire are actually formed undersea. They're marine sediments. This is a classic example. Okay, it's in Aberystwyth. I've strayed into Wales again. But each of these layers represents possibly one storm. And the point was, at one point, this was at the very bottom of a fairly deep ocean. And come an autumn storm, sediments that had laid down on the continental shelf might all, in a great rush, come down canyons under the sea, spread out in fans, and form one of these layers, which eventually solidify. So that's a turbidite. And the one on the right bottom is sediments in Triassic rocks, let's say many wind blown, but again, quite well sedimented. And I had to pop in the one above it because it's an absolutely fascinating thing, which really shows that mid Wales was once, for millions of years, quite a deep ocean. And this is called the drinking stone. You'll find it if you go from Gleneaglois into Hafren Forest on your right as you enter the forest. And this stone actually comes from well up the hill. It's Silurian, and it actually rolled down the hill, exposing the bottom of this big stone rock. And that shows a lot of casts. which actually represent the bottom of the sea. It's like a mold for this these Silurian sediments, and of course they hardened, and now they've been exposed in this wonderful drinking stone, as it's called. There's mythology connected with it, is why it's called the drinking stone. But I exhort you, once we're allowed out, to go to Hutton Forest and have a look at this, because it's amazing. Next. All right, and here we are, the ultimate sedimentary landscape. It's almost as good as Canada. I'm sure you know where this is, but there we are. This is the old red sandstones of the Brecon Beacons laid down. These sediments were formed from the erosion of the huge mountains, the Caledonian Mountains, of which are Cambrian Mountains in Wales and Scotland, and the Appalachians and the Norwegian Mountains are all parts of an immensely long mountain range. So these were formed in the Devonian, and each of these eras lasted millions and millions of years. So it takes a long time for this to happen. But this is a wonderful example. Next, please. Oh, and this is another little snippet, really. On our trip to Arran last summer, we were shown this, which is a famous geologist in the 19th century called Hutton. Noticed that the rocks went in were all in layers, but there was a sudden break, and then there was a layer going in a totally different direction on top, which is on top, yes. So the lower rocks are what we call Dalradian schists, extremely old sedimentary rocks, very old, very hard, which cover this part of Scotland, but have been tipped up when these Caledonian Mountains were formed, and then eroded off to some extent, and then the old red sandstones formed layers on top in a totally different orientation. All right, then this is the last type, metamorphic rocks. Now, we're not very rich on metamorphic rocks in Shropshire, but we do have them. And these, in fact, are the oldest rocks in Shropshire, which I recently went to hunt out. They're extremely underwhelming. You'd probably walk over them without noticing, but they're called the Rushton schists, and they're exposed along a little track between the village of Rushton and Uppington, which is west of the Wrekin, in a very small area. And there's some actually in the village of Rushton itself, so you don't need to go anywhere. And these are extremely ancient rocks that form the basement of most of the Midlands. So they underlie the Wrekin, they pop up again underneath the Malvern Hills, and in various places throughout the Midlands, you will be for little hints of the Rushton schist, which are very ancient. And they have been cooked and churned and turned over time and time again, probably. I brought a little bit of this rock home, a bit naughty, but I think it's the one on down on the right there. Smashed it open, and you can actually see what we call foliation. You can see that it's all in lines and there are different minerals in there. You can see that it's a very ancient rock, really. Carry on. There's also one other metamorphic type of rock, equally old, just on the little, if you go back to the one before. Oh no, it hasn't, that picture. Sorry, no, as you were. This is called Primrose Hill Gneiss, which is also a very ancient rock. And many of you will have been to Scotland and be aware that the whole of the far northwest of Scotland is made of gneiss, which are immensely old rocks, basement rocks, very strong, but they've been metamorphosed and metamorphosed again, and then uplifted and then eroded round and round and round. These two rocks are from this little, there's only very small exposure in Shropshire, and I have to confess I was too lazy to go up and find them, because it's a little way up the Wrekin. But there we are, these red granophyres, which are volcanic rocks, are interspersed with them, but they're rather different. And here's another metamorphic rock, which is quite near Shropshire, but I'm not aware we've got any actual slate quarries, but I rather like this picture. These happy chaps are all cutting slates at Llangunnog, up the top of the Tanat Valley. And slates are formed by squeezing and squeezing of mudstones until they harden and cook, and then can be split, and they're roof tiles. Yeah, there we are now. Okay, and I've set up a little rock factory at home just to show you this sequence again. This is sand, a little bit of sand. Sand is all squashed up and cooked a bit and forms the Triassic sandstones, the new red sandstone. This is old red sandstone, a little bit harder, and that's quartzite from the Stiper stones, which is, I don't think it is actually a metamorphic rock, but it's certainly come from sand. Here we have mudstones, my modelling clay, and I enjoy myself doing a bit of pottery, which is cooking sand, cooking clay and muds. And then you can, this forms shales, which form an awful lot of mid-Wales and mudstones of various sorts. And then you cook those a good deal more, and you will get something like this on the right. You get the slates first, but if that's all recycled, there you are with these wonderful stripy rocks, which I think came from New Zealand. Again, like the gneisses, they're recycled rocks over millennia. And the one down in the middle is something we call an ophiolite rock, which is a rock that's been pulled down into the crust and then spat out again and cooked and cooked and cooked at immensely high pressures and temperatures. And they form these rather wonderful sort of soapy looking rocks that you find at the Lizard, if anyone's ever been there, and various other places. And here we have shells crushed up, shells squashed together to form limestones. Here we have the limestones. And if you cook a limestone, it turns into marble. So we don't really have any marbles in Shropshire. That's from New Zealand as well, but that's the process of developing a marble. Right, well, let me introduce my chum, Billy. Billy, I gather that these days it's very de rigueur to have your goat on your Zoom call. So Billy is here and he's telling me it's time for a little bit of a break, because what we've done is the elementary stuff, but what's coming next is the hard stuff. So you need to concentrate very hard. All right, well, yeah. But here we are. Right. About 3 years ago, Charles and I were extremely lucky. We went and had a holiday in New Zealand. We went there because our youngest daughter, who is an ornithologist, had been doing some research on South Island, the northeast part of South Island, and had the very unfortunate experience of being in the middle of a massive earthquake while they were in a place called Blenheim. We'd booked to go out and join them, but in fact they came back, they were so shooken up. And we went there, and friends of ours took us to see this, which is in fact uplifted shore, marine rocks that have been, they just literally overnight lifted up, came out of the sea about 20, 30 feet. Those are all corals. And quite astonishing sight. And that's because this part of New Zealand is right next to a subduction zone. And it split, basically. And it was like a, let's say, an arrow that had been pulled. The forces were suddenly released, and the rocks near the coast were like this. And as the tectonic split, oh, can't they? No. Oh, sorry. How am I going to tell them? As it split,
I'm going to move on to the next slide.
It pinged up anyway, and there was uplift. This is what caused tsunamis. Now, I'm sure you're all aware that it was discovered not so long ago that... Okay, here's the plate we're talking about. Yeah, we were right here. No, South Island, Charles, there we are. Right there. That the Earth's crust is divided into these plates, which move around. infinitely slowly, about the rate of your growing fingernails. And throughout geological history, these plates have, the continents have moved aboard these plates. Move down to the next one. And the process by which this happened, which was only elucidated, as they say, in about the mid-1960s, although it had been suspected by many a geologist, particularly someone called Alfred Wegener, who noticed that Africa and South America seemed to fit together, and other parts of the world, there seemed to be a fit. And indeed, they had been joined together, but the mechanism wasn't understood till just post-war. Ships doing surveys in the Atlantic discovered that right in the middle of the Atlantic, there was a very immensely long range of hills. And they saw there was a ridge that went right the way down the Atlantic. And a similar one was found in the Pacific. And they realized that crust was actually being formed in the center of this range of mountains, forming new crust, which was pushing out either side. Wegener had realized that this must be happening, but couldn't work out how on earth the world wasn't getting bigger and bigger to accommodate this, until it was realized that this process called subduction was happening, that these crusts, which are made of lighter rock than the crust making up the continents, was actually diving down into the earth. And they're all around island arcs and sort of next to continents, the deep trenches where this happens. So we have a volcanic island arc like Caribbean. There are also, to boot, things called hotspots, little holes in the lithosphere accessing the plume. And there are quite a number of these around, dotted around the earth, the most famous being probably Yellowstone, which is a hot spot where the Earth's crust is thinned and where we're expecting a super volcano quite soon. And as the plates subduct, they drag water down with them and the surface rocks. Some of the surface rocks can get sort of escape, and these are the ophiolites, which we've got near here, actually in Anglesey, you'll find ophiolites, and in the Lizard. But at a certain depth, everything melts, and then there's the pressure of the water pushes the melted rock up, and you get these extremely explosive volcanoes like Mount St. Helens, all forming lines somewhat inland from the coast. Also, behind the volcanoes, you need to note this, you get a bit of the crust that's been stretched, and quite often it sags, and this is called a back arc, and that's relevant to Shropshire geology. Remember the word back arc. Now, carry on, Charles. Yeah. There's another diagram, which is a somewhat simplified version of what I've just told you, but I'm relating it to the geology of Shropshire in the Ordovician Silurian age. There was a continent, the rocks that formed southern Britain were at that time on a small continent called Avalonia, and it was moving towards a huge continent called Laurasia that actually carried the rocks that became Scotland and Northern Ireland. They were pushing towards each other, and then there was a volcanic island arc which actually was sited over Southeast Ireland, the Lake District, which in those days were this volcanic arc. The Iapetus closed ocean was closing by subduction, causing these volcanoes. Behind was a basin which actually became the Welsh Basin as it drew near. It sagged and lots of sediments settled. Now, in a later stage, Laurasia actually banged into this island arc, pushed it up, and these are the Cambrian mountains gently rising to form this huge line of Caledonides. And the subduction started much nearer to Shropshire and formed lines of volcanoes, of which, let's say, Stapley Hill is some. These are much younger than the Urconian volcanoes, but they were also formed with a similar process eons before. Eventually, the two parts of the crust totally collided and pushed up a large amount, a lot of crust, and formed these high Caledonian mountains. So at that point, Shropshire and the Welsh Basin were uplifted, inverted, and turned into high mountains. A process that's very similar to what's happening in the Himalayas right now. Since when they actually went up to 13,000, 14,000 feet in their heyday, but have eroded down. Carry on. All right. Oh yes, yeah, right. I hope you're not terribly bored by now, but I'm now going to go through these geological eras probably fairly quickly if I can. You see there's a lovely multicolored map basically showing that Shropshire is immensely rich in its varied rocks. I think we've got 11 of the 13 geological eras represented in our county. So there we are, move on. Yes. Now, the most amazing thing is that, right, we're right at the bottom here. We're in the precambrian. This is right, the oldest rocks in Shropshire. So at this time, we've gone through all these eons and eons and eons with all sorts of things happening. You know, what became Shropshire's wandered all over the place on plates. But I won't go into detail there because that's too much, but carry on. Where we were, these little red dots represent where Britain was on the globe at that time. And these have been discovered using a kind of something called paleomagnetism. I have to admit that I've looked at a lot of different books in the last week or so, and none of them completely agree, because it's very, very difficult to look back 550 million years and be quite sure. But through the fact that rocks as they form take up the magnetic field of the Earth, it can be worked out largely where they were at a certain time. And also fossils are very useful for this, because fossils, if they're very different, and then two continents collide and the fossils become very the same, you know that they've been widely separated. And this is how they fell to the fact that England and Scotland were widely separated. But there we are on this sliver of continent called Avalonia, above a huge continent. And not long before this had all been one supercontinent. The continents all joined together at least 4 times in known geological history, but this is the end of the 3rd episode. We're right over the South Pole, or very close to the South Pole, 60 degrees south, being carried north on this little sliver called Avalonia. Scotland, meanwhile, and Northern Ireland are sitting on another plate called Laurentia, which is essentially what became North America and Greenland, ultimately, as you see from the map. Between them, there's a great big rift. And at this point in the Cambrian, that ocean, which we call the Iapetus Ocean, is still widening. It's been rifting and it's widening. This the globe on the, if you'd been, you know, Hitchhiker's Guide to the Galaxy, going wandering around the outer space, that's how the world would have looked at that end of the Precambrian. And there was a huge ice age at that time. It's called Snowball Earth. Almost the whole of the Earth was covered in ice. And we've had a number of ice ages throughout the last 700 million years, about which more later. And there we are at the edge of this continent, which we called, is generally called Rodinia. I found various names for it, but Rodinia will do. And this is the time, 550 million years ago, when the Urconian volcanoes of Shropshire were erupting. And there was a lot of rifting going on as Avalonia split from Gondwana land, which carried the rocks that ultimately became South America, Africa, India, Antarctica, as you see next. And that's what Shropshire would have looked like. Rather nice, I think. If on the right, you can imagine those are the volcanoes. We've got the Wrekin and the Raglith and Caer Caradoc and the Lawley. And on the right, you've got, on the left, sorry, you've got Earls Hill and Ponsford. And in between there's sea, because we're on the edge of the continent. Life has taken off, but it's still pretty primitive. These great big things are called stromatolites, which you can still find. They still exist on the west coast of Australia. And they're busy doing chemical processes that are releasing oxygen and enriching the atmosphere. And that's another whole story, is how life developed. And and here we are with our ancient Precambrian rocks. This is the Rushton schist I was telling you about. Very unimpressive, but that is it. That's all there is. And the gneisses are up on this bump here, which is Primrose Hill at the end of the Wrekin. So those are our oldest Precambrian rocks. Next, please. Don't use that. Oh yes. Here are some more Precambrian rocks. Rushton schist to the left. These are rocks from the Urconian volcanoes. And these are the Longmen sediments, which are also Precambrian. I'll tell you a bit more about those in a minute. Next. I don't know how many people have been to the Urcle. If you haven't been, go. Fascinating. This is a country park just on the outskirts of Wellington, on the northeast end of the Wrekin, which demonstrate a whole plethora of volcanic processes. There's a large quarry, and the rocks here are mainly rhyolite, which is a red sticky volcanic rock, this red thing at the bottom here, and this red granophyre. And in fact, it's the rock you see as you come along the M54, after you've coming west, as you've gone past the Wrekin, you know, you go through a cutting and it's wonderful red rock. Well, this is the rhyolites from this area in the M54 cutting. And at the right end of it, there is what we call another unconformity. There's a break in the succession of rocks, and the rocks on the right are Cambrian sediments. So the next tier are sediments, but there's a long timeline between the laying down of the volcanic rocks, or the eruption of the volcanic rock, and these Cambrian rocks. Can't see it very well there, but okay. Next, please. All right. Okay, at this point in the Precambrian, these important faults developed in Shropshire. As you see now, the Church Stretton fault is the most important. This is a very deep split in the Earth's crust, which was very active for millions and millions of years, and in fact is still active. Many of you will remember the earthquake, fairly decent earthquake thinking about 1984, that shook a few chimneys down, that showed that this fault is still moving. And to the right, it does extend right down into South Wales. On the top right, it extends through Lilleshall, where the northernmost igneous rocks come out. And I heard recently that apparently somebody in 1920 was drilling for new coal fields in Stoke-on-Trent. Instead of finding coal, they found igneous rocks well down, And the chemistry of these rocks was identical to the rocks here in Shropshire. So it seems as if the Stretton fault extends right up into Stoke-on-Trent area, where it actually coincides with another important fault, which is not shown on this. Yes, it is, right to the bottom right-hand corner, which goes almost directly north-south, which is the fault carrying the Malvern Hills. And these are all part of the extremely ancient basement rocks of the Midlands, the Midland platform. But as you see, there are faults all over the place. They're showing lines of stress, mostly orientated northeast and southwest. And on my picture to the right, you see this second one is the left, yes, the Ponsford-Linley fault. This scythes through the Shropshire Hills, is another important fault and delineates the west side of the Longmen, which is also formed from precambrian rocks, which are unique to Shropshire. And actually, if you picture that picture I've just shown you of what it would have looked like, there's a deep sea between the two volcanic fault lines, which at that time would have been islands. Sediments formed in this basin. Next, please. Yeah. Oh, no. Oh dear, sorry.
Is that too far?
No, it wasn't the one I wanted, but we juggled these. These are just pictures of these, but I expect you're familiar maybe with them. The Ponsford-Linley fault, these are not rather difficult to see, but that's Earls Hill and Ponsford Hill, which are volcanic hills. And if you drive up through Haberley towards the bottom of the bridges, you will see these lines of hills, which are also, that's the east side of the Longmen, but bounded by volcanic hills. Next, and these are our famous Stretton fault mountains, looking up to the Wrekin along the Lawley, and to the right, down below, looking at Caradoc and the Lawley and Raglith Hill in the near side. And I recently went and found my way to Wart Hill, which is the southernmost in Shropshire, the southernmost volcanic hill in this line, and you get a good view right up the fault line. And the picture on the bottom right, which CPRE members will be very familiar with, is the winning photo from our photographic competition last year, taken from the top of the Burway on the Longmen, looking at the volcanoes. Next. Right, here we are showing you the formation of the Longmen. So we've got our volcanoes either side, with the basement of rushed and schist, and the formation of the faults, which caused a lot of sagging of the crust in the bit between, and erosion happened, and a shallow trough developed. And then forces from the side started to bring the two together, and they were uplifted, and all the sediments that had accumulated were deformed in a very peculiar way. And they formed this very, very deep syncline here, as you see here, and up in the on the right, very, very deep syncline, which is what the Longmen basically is. All sediments from the Precambrian, but among the sediments there are lots and lots of signs of volcanic ash and dikes, which are lines of volcanic rock through them. So as you drive along through the Longmen, you will see that the lines of sediment are very evident, but they change direction as you go across. It's a very remarkable place, and it's extended further north. The same rocks form Lythe Hill, the Hormond Hill is made of Longmendian rocks, and the quarry that they're quarrying away, it's called Sharpston Quarry. There we are. So here we are. We're looking at the Longmen from around Norbury. This whalebone. You know, you could easily miss it, not realise it was important Precambrian because it looks rather like other hills, but it is unique to Shropshire. Here's the wall made of the Precambrian Longmendian rocks, and Cardigan Valley, which was carved by glaciers in the last ice age. So the glaciers found lines of weakness in these rocks. And this is the first reasonably complex life, the Ediacara fossils. They were discovered not all that long ago in the Longmendian rocks. I won't go into detail there. These are very, very simple life forms, not dissimilar to the Charnia rocks that were found in Charnwood Forest. They're soft-bodied. There were no hard shells, and they were very strange life forms. Lots being found out about them in the last 10 or 15 years using various techniques, but they're rather remarkable. Anyway, next, please. Oh, no. Hang on. Okay, well, we're moving on now from Precambrian to Cambrian, the next big era. Now, what's remarkable about the Cambrian is that the big southern continent was breaking up. Avalonia was beginning to move north. And by breaking up, an awful lot of shallow seashores were found all over the world, which gave perfect environments for rapid evolution. So we got the Cambrian explosion of life, the evolution of hard parts to animals, exoskeletons, and the beginning of predation. Animals learned to eat each other, and an absolute proliferation of different sorts of life, famously the Burgess shales, which you've probably heard of. So the two parts of Britain are still very widely separated. We're still right down in the southern latitudes, 60 degrees south, but slowly moving north across this closing ocean. And note here the continent on the blue is called Baltica, what eventually became Scandinavia and Western Russia. That's getting a bit nearer. Okay, and that's what these wonderful Cambrian marine biota look like. Very bizarre animals, extremely strange. The Burgess shale was found in Canada in about 1906 by someone called Walcott, and have been very extensively studied. And other similar sets of life have been found in China, in Newfoundland, a place called Mistaken Point. So the fact they were very bizarre has been replicated elsewhere. And the sad thing is that they nearly all died out at the end of the Cambrian. There was a mass extinction. So very few of these lived to tell the tale, so to speak. But you'll notice these beasties at the bottom. These are trilobites, and some of these did survive and move on into the next eras, and in fact survived and evolved for millions of years. And here we are in Shropshire, the Cambrian. I'll show you, I've already explained these Cambrian shales sediments at the side of the Urcle. At the bottom here, you'll see, I rather like this picture. This is a trip in 1896 of Cambridge University students via Birmingham University, which I had the pleasure of attending for 6 years. And there were 5 final year students who were all female, which is astonishing because I didn't know that girls were let loose on the rocks at that stage, all bashing away at Cumley Quarry, which is just at the bottom of Cair Caradoc, where some early Cambrian rocks, which were really the solidified oceans next to the volcanic islands. And they found olonid trilobites. Only I've found out just this week that they didn't actually find an olonid trilobite. They found a head and they found a tail, and they didn't have a clue what was in between them. And I've seen a lot of correspondence between these fine researchers debating what the beastie looked between, but they've been found elsewhere. These are the first Cambrian olid honor. And this on the right is called a graptolite. And these are very, very important life forms in the Cambrian because they evolve very rapidly. And they're very useful for matching different areas of the world to see where they were joined, because the graptolites take different forms. Probably why we know that Scotland and Ireland want a totally different part of the world. So the Cambrian hosted a number of rocks that are very important, in fact, in in the geology of Shropshire. Mudstones that became the Mytton flags. Though I've seen some debate that they might be actually Ordovician rock. But there are quite a lot of early Cambrian rocks. The Hoare Edge rocks, just to the west of the Lawley, there's a sharp ridge, Hoare Edge, which is Cambrian. And the Cambrian rocks you probably know best are in Wales, the Harlech Dome, all the rocks inland from Harlech. They're Cambrian, very old, very sands. All set right. What's that? What's that? Take that away.
Ordovician. Right,
moving on to the Ordovician now. This is a rather violent era. The Ordovician ended in another great big ice age, which had a devastating effect on the life that had evolved. And next, please. Here we are in the Ordovician. Oh, no, go back. No. The Ordovician, you'll see that Avalonia has moved across the Iapetus Ocean, moved quite a way north, and to the south, another ocean is opening up between Avalonia and Gondwana called the Rhyic Ocean. Note this, very important. There's an ocean between Avalonia and Baltica called the Tornquist Ocean, and subduction zones between Avalonia and Laurentia, where Scotland was hosted. But Avalonia is quite briskly moving north at this stage in the Avalonia, in the Ordovician. And in the end of the Ordovician, it actually docked with Baltica. It actually fused with it, but in a rather gentle way, because Baltica kind of hit it on an oblique angle, but the rocks fused together. So we got joined to what later became Scandinavia. This is the time when the Welsh Basin had active volcanoes around it and was filling with sediments, marine sediments. And the shore and the middle of what's now southern England was occupied by a very old, very hard platform, these Russian schists. And Shropshire was right at the shoreline, which moved, but was basically determined by the fault line, by the Stretton fault. So we had island arc volcanism surrounded by water. And then we got this ice age and another mass extinction. But there was rich life during the Ordovician. And a lot of Shropshire rocks are Ordovician. Carry on. This is what life was like. Lots of shorelines, lots of newly evolving, because the Cambrian biota had sort of largely become extinct, but we've still got a trilobite there, my favourite little beastie. We've also got very, very early plant life evolving at this stage, mainly still in the sea. but this is an important leap forward. Next, please. And here again, a little bit complicated, but this is what was happening with the subduction zones. As you see, here's Avalonia. You're looking the other way now, but it's moving across the ocean. This new ocean is forming between Avalonia and Gondwana in the south. You've got a couple of, they've got an island arc here, which is Ireland and the Lake District. You've got volcanoes much nearer, and that's basically Snowdonia that was erupting, Cadaridris, and all the little volcanoes in like Stately Hill, the Brython that was coming up. It was very, very active because we've got these subduction zones near the coast. The Iapetus was still quite wide, but we were heading sort of north towards the Laurentia. Here in the next one, you see the Iapetus Ocean has closed a little bit more. The Rhyak Ocean has opened a bit more. So we're moving across. Some of these subduction zones are sort of dying out in Middle Ordovician, but we've still got active volcanism. And at the bottom, you see things have quietened down quite a lot. And we're now at 25 to 30 degrees south. And the Rhyak Ocean is very wide. So here we are, we're traveling north. So, and our great journey over the earth. Okay. Yeah, there we are. There are Cambrian, Ordovician rocks. I get a bit confused here, but the Nipstone and the Stiperstones are from the early Ordovician, and they're a shoreline on this sea. The wonderful quartzites on the Stiperstones are formed from the sands on the shores of these seas as we move north, which hardened over the millennia into this very, very hard quartzite. You look into Wales from the Oswestry Hills and you'll see a lot of little bumpy hills. Those are all Ordovician. And a quick curveball story. I was in South Queensland about 5 years ago with my daughter. I worked in Australia for a while. And I looked at the hills just inland from Fraser Island. I thought those hills look enormously familiar, the shape of them. And I found out later they were indeed Ordovician hills. And incredibly, it's possible that they actually formed in the same region of the earth as our own Ordovician hills. Before that part of Australia was connected to us when Gondwana was near Avalonia, and then it wandered off into a different direction. So this is the beauty of geology. You suddenly sort of connect with other parts of the world and recognize the types of landscapes. So this time here we are, Brython and Morlagova shot up out of the deep seas. Okay. Yep. And here we are, just a few of the Ordovician rocks. The Betton Dingle, which is where is it? Near Wortham, said to host a lot of trilobites, but they're quite hard to find. And there's a quarry nearby called Lower Wood, which is igneous rocks. And these are mudstones. You'll find a lot in Wales of these dark mudstones. The fact that they're dark shows it's what we call anoxic. Life there was very scant because there wasn't any oxygen, because they're buried under feet of mud. There wasn't much life, and they end up being very dark, but they're also very light mudstones in mid Wales. So, and these are examples. The Mitten flag is the one in the middle, very, very important, because they host the fluids, the hydrothermal fluids that carried all the minerals. So that's where the lead came, but that didn't happen for quite a long time afterwards. Carry on then, Charles. Yeah, and this is my pride and joy. These are some Ordovician trinuclear trilobites that I found my very self, not actually in Shropshire, near Landrin Wells. There are some Ordovician volcanoes just to the east of Landrin Wells. And on a geology trip 20 years ago, we sat in a quarry and smashed up a whole lot of shales there, and out came these exquisite little trilobites. And you could actually see that these shales were burnt. This was a mass extinction because the volcanoes pushed up through this mud and killed all the life. And you can actually say, so you could see burn marks on the rocks there. So there we are, those are my trilobites. Trilobites, carry on. Right, Silurian, important era for Shropshire. I'm sorry it's all a bit repetitive, but don't worry if you don't take this in, because I know it's very difficult to absorb it all. So this is going to go out as a podcast later. There are plenty of books that explain all this, which I'll show you later. And so you won't take it all in, I know. It's taken me years to unravel all this myself. Okay, in the Silurian, Shropshire is now about 20 degrees south. It's about where Greece is now. So you imagine the seas round Greece. It has actually fused now with what became Scotland over on the left here. It's also fused with Baltica, and it's all forming a new super plate called Laurussia. That's what's termed. This big ocean, the Rhyic Ocean, is at its maximum. Now, in Shropshire, there were shorelines and a lot of reefs because it was a nice warm water, and reefs were built everywhere, which form the rocks on Wenlock Edge. I'm sure that you know about that. Clun Forest are also Silurian rocks. The Long Mountain. It's a very common rock in Shropshire and very important as well. It's quite a limey rock because of it being made from organic reef building organisms. And here you see we are sitting on the edge of the Rhyic Ocean with shallow and as the continents fused, they threw up the Caledonian Mountains, an immensely long chain of mountains, which are Cambrian Mountains and the Scottish Mountains, as I've said. Move on. Yeah. This is just to summarize here. Here we are with the suture, in fact, goes along this line. All the rocks north of that, which is why the Scottish rocks are different colours, have come from somewhere else. The Iapetus suture starts sort of in the Solway Firth. Just south of it are the Lake District, the Isle of Man and Southwest Island. These were the island arcs that developed at the edge of the subduction zone. Further south, right, the blue bit is what the Midland Platform. This is the stable piece of crust in the centre of Avalonia, and it pops up in several places in the Midlands. We've got it in Shropshire, but you'll find little fragments in, say, Dudley, the hill with the tower on top at Dudley. That's precambrian. And Charnwood Forest, if anyone's ever been there. If you haven't, go, because it's rather interesting. That pops out of the coalfields around Leicester. And the Malvern Hills, of course, precambrian. So that's what you see. Yeah, there's the long fault that goes up Stoke-on-Trent, and the buried volcano, which is called the Apedale volcano. Okay, move on. All right, and here we are on Wenlock Edge 425 million years ago, which I'd rather like to go to because it looks very, very inviting. Subtropical, very clear oceans, absolutely teeming with life. Yeah, and there we are. There's Wenlock Edge. As you know, it's quite straight. And here on the right, we can see the actual reefs below these lines. So that's it. That's the coral reef. And if you look at these rocks closely, I'm sure a lot of you will have been. You actually see the corals and lots of fossils. Now here's our wonderful branch manager who lives in Clun Forest. We recently went to have a look at her new field where she's planted a lot of trees. And although she's on the Silurian rocks, I was a little bit puzzled because the soil is very red there. And it turns out that the rocks at the top of Clun Forest are in fact Devonian or late Silurian, when the earth had moved into a rather desert-like environment. So the soils are red from oxidized iron, but there we are. And on the right, this is a quarry in the Clun Forest area, beautifully bedded silty limestones of Clun Forest. Big. And the Clun, I mean, like the Long Mountain, Silurian landscapes tend to be quite gentle. The Long Mountain is a big syncline in sedimentary rocks, so you can really recognize those. Okay, carry on. Now, just another little curveball. Incredibly, at this time, as you know, we'd fused with the bit of crust that became America. It is reputed that we were once connected to the Niagara escarpment. Niagara falls over an escarpment made from Silurian rocks of exactly the same age as Wenlock Edge. And an immensely long escarpment goes along North New York State through Ontario and delineates the north side of the Great Lakes. And that was apparently a shoreline way back in Silurian times. So how true that is, I don't know, but I've read it in a few different places, so maybe. Here are the building stones in Clun, which are Silurian, sort of light coloured stones. Here's a few Silurian, some of my Silurian fossils. These come from Wenlock Edge. And this is the pentamerous I was telling you around, the rock that's practically made from these brachiopods. It's called government rock because, as you see on the right, there's like an arrow here. That's the suture in the middle of the brachiopod. And when it erodes, it forms these arrows, which is like what used to be on prisoners' uniforms, apparently. They were incarcerated courtesy of the government or Her Majesty, so it's called government rock. That's just the side. Right, okay. I've said any questions. If you've got burning questions, you can put them on your chat thing. Otherwise, because there's an awful lot to take in and it's spoken for quite a while already.
Sally, we do have some, yeah.
Pardon?
We do have some questions, if you don't mind just taking a couple right now that have been dropped in.
All right, yes. I have to hasten to say, I'm not a professional geologist, I'm an amateur geologist, even if I've been poking around rocks for many, many years. So I don't know whether I will be able to answer, but I'm sure I can find someone who will. Yes, okay.
So we've got a question here from Bernard O'Connor. It says, was there no chalk in Shropshire? Was it glacially removed?
I would imagine it was removed well before that, actually. I expect the glaciers might have finished the process off, but the real reason we don't have chalk is that the whole of southeast England was tipped up. Much more recently, I'm sure you're aware there are a lot of volcanoes in northwest Scotland, and that's because a great rift appeared in this continent we've been talking around in Laurasia, which we'll come to in a bit, tipping the whole of Britain up, and therefore the top rocks were the first to get eroded off. So it's likely that that was eroded well before the glaciers, but You know, we had glaciers for 20,000 years and they will have removed an awful lot of rock. Yes. So that's my answer for that.
Thank you. Another one from Bernard. How high were Mind and Clee Hills before glaciation?
How high were the Mind and Clee Hills? I've no idea. That's my honest answer. I don't know if Mind was very high because it was a syncline that went down into the earth. I'm sure it was a lot higher than it is now, but there won't have been giant mountains, not like the Caledonian Mountains. So I don't know exactly. A bit higher. Let's guess 3,000 feet, let's say. Okay.
Final one here from just in the chat from Scott. Most interesting. How did Wenlock Edge Reef form?
Oh, well, in the same way that the Great Barrier Reef formed, very, very shallow sea. So a lot of sunshine could get down to the sea floor and corals grew. They weren't quite the same as modern corals, but not that different, which are actually animals. Huge colonies of these animals grew all over the floor of the shallow seas, and attracted a huge number of other species as well. So really, essentially, that's it. You know, the same way that Great Barrier Reef is now, and the Bahamas, and anywhere shallow, with a lot of sunshine that could get through and allow heat. I won't say photosynthesis because they're not plants, but yeah. Anyway, shall we rack it on, Connor? Because the time is going, and I'm sure people are getting very fidgety. But if you want to get a coffee or a beer, I'm sure Billy the goat won't mind. Right, we're in the Devonian now. This is the next era. We're getting further north now. We're really quite near the equator now. We're where the Namibian desert is now, just south of the equator, very dry. The ocean to the south is beginning to close. So just off the south coast of of Britain, this large ocean is being squeezed by Gondwana in the south. But we're in a very, very hot, dry, desert-like environment, quite near to the newly uplifted Caledonian Mountains, which were rapidly eroding. There were flash floods, as you remember back to the beginning of the talk, picture of the braided rivers in Iceland and New Zealand, which carrying enormous amounts of sediment were rushing down from these hills and dumping everything on one place, and a whole continent developed called the old red sandstone continent. At that time, the shoreline at the bottom here was around Somerset, and the Devonian rocks of this age south of there were marine limestone. So if you go to Torquay, for instance, you'll find Devonian rocks, but they're completely different because they were formed underwater. They were formed as they're more like the Wenlock Edge limestones. So the line from, let's say, Haverfordwest right across South Wales, across through Bristol and out to the southeast around Dover or somewhere is the southern limit of Britain at that stage. And what lies below that came from the closure of the Rhyic Ocean. Evolution was taking off a bit. This Devonian is known as the age of the fish. Huge numbers of fish evolved. Something called coelacanths, which you've probably heard of, like lungfish, which actually somebody actually fished a living one out of the southern oceans around Madagascar some years ago. And no one knew that they were still there. They thought they'd long died, but coelacanths are still alive and well and have stopped evolving to some extent. And there were also very early land plants. There's in Scotland, in northeast Scotland, a lot of fine Devonian rocks. And there's something called the Rinny Cherts, which host very early plants called Cooksonia plants, very primitive plants. But land, you know, the life was climbing out of the seas at this, beginning to climb out of the seas. Here we are. There we are, they're coming out. So fish were developing legs and beginning to get out of the seas, and primitive plants were beginning to colonize the land. Yeah. Okay, and this is a picture of this old red sandstone continent, which was extremely widespread. And you'll find these old red sandstone rocks all over plants around, well, as I say, as far as Alaska, really. Formed from eroding rocks in the Devonian period. Okay, and here are main Devonian rocks of the Clee Hills. The main bulk of both Clee Hills are Devonian. But it widens out in South Wales. All the Brecon Beacons, Herefordshire is practically made of Devonian rocks. It's a bit boring. This is Tugford Church, which is just below the bottom of, there's a big shelf just below the main Clee Hills. In fact, there's a line of limestone, and this is at the bottom, a place called Tugford. And the good lady there is our recently retired president, Sarah Berry, chairman, yes, who happens to live at this place. Here's the old red sandstone, very fine building stones, very hard old rock. Right, here we are. This is my piece of Ditton Plateau from just above Sarah's house in the Clee Hills. And here is the coelacanth, which I did not find. I'd love to find it. But there are very fine sandstones in northeast Scotland that host a lot of these fossil fish. Fascinating. Right, moving on. Carboniferous. This is probably the most important era for Shropshire because it produced all the rocks which have been vitally important for the industries in Shropshire. In fact, responsible for the Industrial Revolution. At this point, we're slap on the equator. We're crossing the equator going north. We're joined up with Scotland. We're right in the middle of this supercontinent that's developed called Pangaea. Practically all the continents have fused. And that has a big effect on the climate and the way life forms. The ocean to the south, the Rhyak Ocean, has closed. So it's slammed up against southern Britain and caused another great orogeny called the Hercynian orogeny. So high mountains formed throughout Brittany, mid-Belgium, Germany, where Gondwana and Laurasia had formed together. Got a tropical climate and abundant life in shallow seas. So though it looks as if it's in the middle of the continent, there were seas from time to time, you know, however many million years, there's a lot of million years. So, and in Shropshire, the carboniferous limestones, which again are reef limestones formed in shallow seas, are very evident in the Oswestry Hills. In Ironbridge, there's a little band at Little Wenlock and at Lillishall. I mean, probably Lannamonach Hill is the most obvious. And that was a shoreline up against a large continent called the Brabant High, which was the Midland Shelf extended to the west, really. We had two lots of carboniferous limestone. Before long, deltas developed. More sandstones were deposited on top of the carboniferous limestone, which formed Kevinstone, millstone grits from the Pennines, equivalent, a very good building stone. And on top of that grew the coal forest. Enormously lush tropical forests of very primitive trees. And Shropshire hosts 4 or 5 coalfields. We've got the one along the Oswestry Hills, the Hanwood, which is all buried. I went to look for it. There's absolutely nothing you can see, but there are slightly poor coal seams underneath, which were exploited until the 1940s. Ironbridge, of course, there are coal fields in Telford. And there's one slap on the top of the Clee Hills, both Clee Hills, developed on top of the Devonian, and coalfields in the Wyre Forest. And this is the age when the mitten flags in Snail Beach were mineralized. So hot hydrothermal fluids flowed into these rocks, depositing their minerals, which is very important to our industries. So next, please. There we are. Here's the wonderful Lycopodia coal-forming forest. Bizarre trees, but very, very lush. And here's the industrial Shropshire, Lanham-on-a-Kill, which until fairly recently was a very, very big quarry producing limestone for agricultural lime. It was burnt in the kilns at the bottom of the hill. Jerk Aqueduct, which is made from this Kefan stone, which is the local equivalent of real stone grit, very good building stone, and used for building aqueducts, viaducts, canal banks, lots of buildings. And here, of course, is an open cast coal mine at Little Wenlock. And this picture was taken in, believe it or not, in 2011. The extent of progress being made at the open cast mine. That would not be a PC thing to say these days. But I thought it was quite interesting to see that's only what, 9 years ago. 10 years ago, it was all reckoned to be a jolly good thing to dig up all this carbon producing coal. That's fortunately not happening anymore. Now here's the building stone. This is Sweeney Mountain, quite near up on the Oswestry Hills. Very good building stone, Carboniferous. Our house is partly built from Carboniferous limestone. And here are the fossils. This is on Arran, small patch of Carboniferous rocks on Arran, where you can actually see the Lycopodium trees embedded in the rock here, fossils. Dolgoch Quarry, just to the west of Luncless, which I go to see the beautiful orchids there, lots of bee orchids there. It's rather a difficult place. You have to go through a very scrubby council estate in the wood that's a bit spooky, but it's worth going because you will find these things on the left here. Gigantoproductus. In the Carboniferous limestone era, the carbon dioxide in the atmosphere went absolutely sky high because there was a lot of carbon around, and animals tended to grow enormous. So there are enormous insects, enormous shells like this one, and these you can see quite clearly in the rocks at the bottom of the quarry. And then up in Trevonen we have the coal, but no one digs it out anymore. But this is the last bit. You can just about see that that's an old coal tip. There is actually rather a nice country park there with display boards telling you about the coal. And these are another of my favourite fossils from the Oswestry racecourse, actually in the Kefan stone, but it's very close to where the limestone is. That's a thing called a spirifer, rather attractive fossils. Next. Oh, right.
More beer.
You might want to
just to cheer you up.
We're nearly there now, you'll be glad to hear. We've got to the Permian now. Right, we're north of the equator now. We're still moving. And we're still in the middle of the Pangaea. All the continents are all together. So now we're where the Sahara Desert is now. So again, we've got very hot, very dry climates with flash floods depositing boulders from the mountains and surrounding hills of any sort, windborne sand dunes. And these are the rocks that form the amazing cliffs at Bridgenorth, where you can see cross bedding. Very bright red, very oxidized rocks. And the north part of Shropshire, because this continent at the bottom, the Hercynian orogeny, bashed up against south of Britain, there was quite a lot of folding going on. So you probably know of the anticline near Ludlow, the Mortimer Forest. That's a Hercynian fold. And the north of Shropshire became a deep, deep basin and filled up with these Permian rocks. That's why you've got a big basin in North Shropshire. And we formed the Nestcliff, Grinshill, Hawkstone hills. They were mineralized with copper and lead. And now we have early reptiles evolving during the Permian period. But for some reason, towards the end of the Permian, there was a very, very big mass extinction. I don't think anyone really knows why, but these mass extinctions tend to coincide with outpourings of lavas from supervolcanoes, which tend to completely poison the atmosphere, pouring out huge quantities of toxic gases. So 96% mortality of marine life. So my dear trilobites were made extinct. That was the end of those. And 70% of terrestrial life. And here's Shropshire, still heading north, but still locked in a continent. Next, please. All right. And these are little jolly fellows that had evolved by the Permian. I wouldn't really like to meet them on a dark night. And these are also Permian rocks in Shropshire, the Albury breccias, which outcrop around Albury, Hardiston. And you can quite clearly see that these are formed from fragments of the Carboniferous limestones embedded in the red desert sandstones. So they're sort of late Carboniferous, early Permian. Very good building stone. There's Albury Castle, Roughton Castle, buildings around there. Okay. And the Permian rocks on North Shropshire, well, we've got the Middle Cliffs, wonderful formations here, great piles of this Albury again. Permo-Triassic, they tend to lump the Permo-Triassic together because they were all desert. And where we live is Permo-Triassic, really. Carry on. All right, now we're moving into the Triassic itself. Next. We're still in the middle of Pangaea, but there are signs of trouble. There's sort of rifting going on. It's getting a lot of stress. The rocks are sort of complaining and beginning to form deep rifts. And in the north, these rifts began to open and a sort of shallow sea encroached across the deserts, or the Zeichstein Sea, mainly from the north, carrying a lot of salt, which evaporated in shallow lakes, forming rock salt. So the equivalent process is happening now around Salt Lake City, Bolivia, Nevada desert, various, in Australia, Lake Eyre, these forming these great evaporites, which, as you know, Cheshire is mined in Cheshire and it forms the basis of chemical industries. So it's faulting rifting, and Grinshill stone formed in the Triassic, which is a very, very important building stone, very good building stone because it's a free stone. It isn't bedded in one direction. You can cut it in any direction. Carry on then. Yeah. So here's the early dinosaurs in the Triassic, wandering around in this desert with some plants. Here we are. We've got the Grinshill here. This is near Clive, Grinshill sandstone. It's not a very good picture, but there's the bridge. Which happens to be on the Sandsaw estate, and our CPRE president is the owner of the Sandsaw estate, so we've been entertained there a few times. Hawkstone, which I expect people know. This is the Hawkstone Hill, which is mineralized. And Grinshill working quarry, still working. I trespassed in there recently because I was looking for a dike. There's a famous line of igneous rocks in the middle of there, but I got chased out in no uncertain terms. Right, here's some more Triassic sandstones at middle. Close to us, we have a copper mine at Urbistock, which is near West Felton, which I poked my head in, but I didn't want to go in very far. It looked rather scary. But that's where a lot of copper ore was extracted until relatively recently. And you may not know that the the portals at 10 Downing Street are made of Grinshill stone. So every time you see our venerable Prime Minister outside his door, he, having dumped his Shropshire-born wife 3 wives ago, however many it is, stands between 2 lines of Grinshill stone. There we are, the various colours on the left at the bottom of Triassic sandstones. The Grinshill stone is pale because of chemical processes that filtrated through the rocks and sort of denuded the irons from them. And there's dikes in there somewhere, but I don't know where. It wasn't allowed to go in. So. All right, and on my lovely trip to Arran Island last September, we were shown this. This is a reptile foot. The Chirotherium on Arran Island on Triassic sandstones, a 12-foot crocodile-like dinosaur precursor. Very definite there. All right, now we're into the Jurassic, and we're nearly there, you'll be glad to hear. We only have 2 very early parts of Jurassic. The Lias, this is the lower and middle Lias, was laid down in Shropshire. And this is actually the rock that forms the Cotswolds. And they're the youngest solid rocks in Shropshire and occur around Priest. There's a little low hill, which is a good 70 or 80 miles from the edge of the Cotswold. It's just a remnant that didn't get eroded off, somehow hung on. So at this point in the world, we have this big ocean here, the Tethys Ocean, which is actually what happened when that closed, was the formation of a hugely long line of mountains, including the Pyrenees, the Alps, the Dinaric Alps, Carpathians, the Iranian mountains and all the oil fields, and the Himalayas, so enormously important. But at the same time, the southern Atlantic Ocean was opening up to the left. There you see, between Africa and North America, there was a gap developing. And these rifting cracks were all opening. And to the northwest of Britain, you see a long red crack, which eventually opened up and formed the North Atlantic. Abundant life at this time. Ammonites had appeared in abundance, and the dinosaurs, of course, were rising. And then all of a sudden, here we are, this is sort of jollies you'll find around the place in the Jurassic. Jurassic Park, incidentally, is misnamed because the dinosaurs they show in the film were actually Cretaceous, from the era of chalk. And this is what you'll see around Priest. All I've ever found is soils that are very definitely Lower Lias, which is reminiscent of the Cotswolds, the parts of the Cotswold, the lower parts of the Cotswold, and the one stone I found up on the top of Priest Hill, which is Middle Lias. And these are the sort of fossils you'll get there. They put the Priest bypass through this hill in 1988, and a lot of fossils appeared, which went into Rowley House Museum, and now are presumably in the Ludlow Museum, because they moved all the wonderful fossils from Rowley House down to Ludlow, which was a huge mistake as far as I'm concerned, because what you find in the new museum is a rather staged, minimalist selection of fossils that, unlike the thousands and thousands of little drawers that you used to be able to look at Rowley House. hard to get. But these are typical Liassic fossils. Okay. So what's happened since then? A lot of erosion. The rocks from the upper Lias, 180 million years ago to about 270,000 years ago, are completely absent in Shropshire. And during this time, as I said, the Tethys Ocean closed. All these mountains were uplifted, causing some gentle folding. Southern Britain was more effective. I mean, around Dorset, the rocks were well deformed by the alpine orogeny, but not up here so much. And then the very important opening of the Atlantic Ocean in about 51, 52 million years ago, with violent volcanism up in Isle of Skye and Mull, and the rifting really took off. Okay, and there is conjecture, and I think it's only conjecture, that there was a hot spot at this time under the Welsh Basin, which actually melted the rocks below the Welsh Basin, allowing it all to slump down. And if you look across Wales, mid Wales, you'll see it's all quite flat, really. It's a great big plateau. They're not big mountains at all, just a plateau. And it's thought that this is because the rocks underneath slumped. This is a theory I've heard recently. Sounds, fairly plausible. And then, of course, there's the mass extinction at the end of the Cretaceous that did for the dinosaurs. That was a major event. Anyway, there we go. That's that. Just to fill you up in what was happening with the Earth in those. This is just a selection. That these are taken from a moving shot, but I thought that would be a bit too complicated. But here we are, late Jurassic. You've got a lot of ocean water around Britain, and here are these rifts beginning to open. Mid-Cretaceous, the North Atlantic is opening a bit, and Spain is beginning to form. There's a lot of more geology down there, but I'm not going to go into that. Early tertiary, 66 million years ago. Atlantic is widening, and by now, the familiar form of the world is pretty obvious by now. Although to the east, Mediterranean, Black Sea area, it's still very nautical, very watery. That hasn't completely. And 20 million years ago, here we are, India has crashed into Asia, crunching up the Tethys Ocean, and we've got the Alps and we've got the Mediterranean Sea, which actually closed and then opened and closed again a few times. So I won't go into all that. That's not Shropshire. Now Charles can't move me on.
We've stopped.
Oh no, you've not done anything?
Let's try another method. That's it.
Oh good. Right, we're nearly there.
Nearly there. Oh, what's going on there?
Oh God. Right. Now, I don't know if Sarah Jameson, our worthy branch manager, is on this call, but she particularly asked me to talk about the ice ages. Well, I think I've talked more than enough already, so I'm going to whiz through this, but it is very important because the ice ages in Shropshire are really extremely important for developing, sort of finishing off the landscape in Shropshire. Now, between 70,000 years ago and 10,000 years ago, there were three major ice ages that affected Shropshire. There were ice ages before this, since 120,000, 200,000 years ago. It's got colder and warmer and colder and warmer. But the late Defensian glaciation was the last one, which was rather important. And the ice sheets came right down through Shropshire. And I'm not going to go into detail because that's another lecture completely. Oh dear. Oh no.
What about this, folks?
There we are. That's just to give you a hint of how far the ice sheets came in the last ice age, the Defensian. It came down into South Wales. there were ice ages that came further south before that, but this is the big one here. Right, carry on. There we are. There's the mammoths wandering around, the famous Condover mammoths. I'm sure you know all about that. Here they are. But that is a picture of an ice cap. It was never as dramatic as this, but the major part of our ice ages, it wouldn't have looked dissimilar with the tops of the hills poking out. So the top of the Clee Hills, the top of the Longmen and Stones would have just poked up above the ice, but they were doing thick, thick, thick ice, and there were glaciers coming down the valleys and across North Shropshire, and a lake at the bottom. You've gone on too quickly. A lake forming at the end. Now, I'm sure you've also heard of Lake Lapworth, which formed across the north of Shropshire, the Shropshire Plain, and altered the course of the River Severn in its time. It used to flow up along the course of the River Dee, changed its course. Carry on. Here we have the River Severn near Leighton, before it enters the Iron Bridge Gorge, going through a wide valley, a glacial trough. I mean, at the end of the ice ages, this would have been filled with ice, grinding away at the rocks. And I had to put in this picture of the Grand Coulee because I've recently been listening to a lot of YouTube from the wonderful professor at Central Washington University talking about Washington geology. And this is what formed in a matter of days. Northern Washington state is covered in enormous amounts of volcanic sheets that came out of rift. Feet and feet. Oh dear, what are they? Basalt, yes. But the ice sheet stopped somewhat north of this and then melted, formed great big meltwater lakes in northern Washington state. And then they needed to find a way out. And in a very, very short time, they burst out of these lakes and eroded straight through these basalt plateaus, forming this thing called the Grand Coulee. Very, very dramatic. And the same thing happened in Shropshire, but to a lesser extent in the ice ages. And of course, the ice glaciers and ice sort of molded the landscape in particularly North Shropshire. You've got, as the glaciers retreated, there were great boulders of ice that formed these kettle holes. And the meres around Ellesmere, as I'm sure you all know, are from the ice ages. Hang on. This is something I'm rather fascinated by. This is an esker, and we have a very good example of an esker in Shropshire near Dorrington, going north, south of Shrewsbury, south of Lythe Hill, parallel to the main A49. And this, in fact, is a subglacial river. Underneath the glaciers, rivers developed with meltwater, carried a lot of sediment down, and that, as the glaciers melted, these rivers actually solidified and formed these ridges called eskers. This is an example from Sweden, but I've not actually seen this esker, and I'm going to go and see it soon. But say we have this feature in Shropshire. Drumlins, lots of little hills that were ice flowing over small bedrock hills, and we have erratics. You know, I mean, a field next to us is filled with rocks that came from the Lake District and Ireland and other places, completely alien rocks. The whole of North Shropshire is covered in till, which is why it's so fertile, these alien rocks. And that's the slickened side. That's what happens when glaciers grind, carrying rocks grind over the bedrock. You get these lines in the rocks called slickened sides. And our famous old Oswestry Hill fort is actually built on a lateral moraine. As the glaciers came south through the Shropshire Plain, they dumped moraine on the side, and Oswestry Hill fort is built on one of these moraines. This is an aerial view of Wixle Moss. Again, this is an Ice Age feature, really. It formed a great hole in the not in the bedrock, in the Triassic sandstones, which then filled up with mosses. The meres, as you're familiar with, there we are, Mere. And here's our Dorrington-esca. Not very evident from above, but you can clearly see there's a long line there. I think there's a golf course over some of it. And here are the famous Condover quarries, which is a lot of glacial till dump. Around Condover, I recommend going visiting. You'll see a lot of glacial features, very obviously bumpy drumlins, moraines, and a lot of rocks. And also around Ellesmere, if you go to the country park south of Ellesmere, you know what, it's near the Tudor Griffiths quarries. Woodhall, I don't know what it is, yeah. But that's a very good place to go and look at glacial tills. Right. Now we have the Anthropocene, which is probably the most important era for moulding the landscape, because that's us. Carry on. And this is an example of what human beings can do to the landscape. This is instantaneous erosion. 2 minutes in December 2019, which we were lucky enough to go and see. At 1 minute to 11, the 4 cooling towers at Buildwas were there. 2 minutes later, they were gone. So it's all a bit irrelevant. So there we are. Now, if you want to know more, or if you want to sort of consolidate what I've told you, these are some books to go and buy, or order on the internet as you do. We can let you know what these are in our mail shop. Particularly, this is the Geology in Shropshire by Peter Toghill is the absolute Bible. And that's where I learned my history of Shropshire from. I think there's a second, well, there are later editions now. Peter Toghill's still alive and kicking, and the great guru for Shropshire. I have met him. This one here, Geological Excursions in Powys, is a wonderful book. If you want to poke into Wales and you want to go along geological routes, it explains all the geology in great detail. And this is a very accessible, if you buy your geological map, you will get these books with them, the big ones, the big maps. And that explains the geology very, very clearly. And then I want you to go exploring. That's the point of this talk. You want to look at, and these are the pieces of it, you know, you must be prepared, because as you know, during geological history, most of the time we were underwater. So I went prepared with my snorkel. Off we go. The end.
Yeah.
Carry on. Thank you. Any questions? And I don't know whether Connor wants to do another plug, but there's a plug, a volcanic plug. That's Devil's Tower in Wyoming.
Thank you, Sally.
All right, Connor. I hope
Brilliant.
the people aren't asleep. It's a bit disturbing because I
There's
can't
still
see.
63 people on the course.
But they could all be
Yes.
asleep. I can't see them.
No, what we
Even
can do,
the random Shoggy's disappeared, though. I think he's fallen asleep.
oh yes,
Yeah.
we've got, oh no, he's there, he's there.
Oh, seriously.
We have a
good.
few questions in the chat box, but anybody who has asked a question, you can, by all means, unmute yourself, and I'll see if I can actually send a request to everybody to do that.
Oh, gosh.
Um,
Oh, golly.
click.
I won't be able to answer all of those, I don't think.
Connor will. You're going to moderate them, Connor.
So
Oh, golly.
let me just scroll to the top.
Oh, Tog Hill's indeed live and kicking in Stretton. Well, I was dreading the fact that he might attend this this talk because his knowledge is second to none.
Most of them aren't questions.
No, they're just comments.
They're people clapping.
Oh, good. Oh, jolly good.
So we have a question from Nick here. So what era is the Witchcliff near?
The Witchcliff. Yeah, I think, are we talking about the bone bed here? The bone bed is at the earliest Devonian, I think. Gosh, I'm going to have. Well, I think we're talking about Mortimer Forest here, which is somewhere I very, very much recommend everyone to go. You go to Ludlow and head into Herefordshire, actually, because it's on the border. There is actually a line of quarries in the Silurian rocks there, which each quarry is in a younger section of the Silurian dome, and you'll find trilobites there. Sorry?
It's not interference.
Oh, is it? Sorry. So that's the Witcliffian. I think we're talking about the bone bed, which is a very, very small exposure just as you turn right to go up on Mortimer Forest, containing a mass of bones and bits of life, and it's all been robbed out, actually. I think that's what you mean. I don't know.
Yes.
Yeah.
Is Bernard O'Connor still with us? Bernard, are you?
I am at the top.
Want to ask your questions, Bernard?
Yeah, the bone bed, is it the result of a mass extinction, or was it?
No, I don't think so. I don't think so. I think it was just a short-ish time when life was very, very, there was a lot of life. So I'm not aware that now you didn't take a shot of the one with my timeline with mass extinctions on it, but I can't recall there was a mass extinction at the end of Silurian. I don't think. I think it was just an extinction. I think a lot of life died for some reason or another. Hang on. No, can't they? Wait a minute. I'm trying to answer the question. Can they still hear me?
Yeah, they can still hear you.
All right.
Yeah.
Yeah.
Hang on. I'm just going to go and do my crib sheet. Whoa.
There.
There. Yeah. Right. Well, there we are. Late. So yeah, there is a mass extinction. Oh yeah. No, there's an ice age. Bit stuck on that one, I'm afraid, but it's early Devonian anyway. I know that the Witcliffian and the bone bed, just at the interface between the Silurian and the Devonian. Okay, another one.
Many thank yous and wonderful talks.
Yeah, well, that's nice. Good. Is it now the time to say, Connor, that if people have been very interested and would like to go and see all these places in the flesh or any particular place, I'm more than happy under the umbrella of CPRE, and we exist to appreciate the countryside, so I don't see why we shouldn't plug geology. I'm very happy to take people to look at these rocks. I'm also happy to give another talk on aspects of Shropshire geology. So if you want to know about fossils, if you want to know about the minerals or a lot more about the Ice Age, just let us know and I'll devise another talk, because this has been great fun to do. It gives one a very good excuse to go poking round backward bits of Shropshire, which is all highly forbidden at the moment, but it won't be soon. And I just do exhort you to buy those books, to really take this in, and then it will infinitely improve your appreciation of the countryside as you go for walks. And start looking for fossils if you haven't found them before. I mean, I've got God knows how many fossils, all the all the walls around our house are covered in rocks. So, you know, I'm going to get buried one day.
Are there any more questions from the floor? Anybody who wants to?
Someone says an outing would be brilliant. Well, I will very much welcome people on my inaugural Silurian safari. How about that? That's Mike's here. Okay. Right,
I've
if
got
there's
a question.
any more.
Before I go,
Yeah.
you mentioned this Samosteus limestone
Yes.
at Abden.
Yeah.
I live not far from Abden, and according to Brecon Hills book, it's now considered wrongly named.
Oh, well, thank you for that, Bernard. It's something I know nothing about at all.
Okay, he identifies it as being very similar to what's called the lower Frome limestone, and that the
yes.
Samosteus was actually a bottom-dwelling fish, rather like that just scavenged the seabed, and that the fossils that were identified in it in the 19th century, which gave it the name, were wrongly identified.
Oh,
and
okay.
so
Yeah, well, I was rather mystified by it. But is there a line of limestone? Is it identifiable as a limestone there?
There are two.
Oh, okay.
There are two.
Yeah. Oh, right.
It's just below the Heath Plateau.
Yes.
Above, it's on the eastern side of the
by the little chapel. I've been seeing the little chapel there.
Before you get there.
Okay.
So it's on the slope as you ascend from the valley of the Cove up onto the heath, on all along that scarp slope. It's a limestone ridge.
Yeah, so it's right the other end of the county for us. So it's a major expedition to get that far from round Oswestry. So I'll make a point of going next time I'm over that way. But there are huge numbers of things. It's an infinitely number of things to find in Shropshire. You can spend a lifetime just looking at the geology in Shropshire, never mind anywhere else, but because it's so intriguing and it changes every 5 minutes. But in this talk, I haven't mentioned all sorts of places that are, it's a bit of a skate over a large number of different types of rocks. But I just wanted to go through all the eras represented in the county. And we are the richest county in England. Nowhere else has 11 out of 13 of the geological eras. So it's fantastically complex. And what I've told you is just the simplest part of it. Each era is divided into a large number of subgroups, which have all been studied till, death us do part, so to speak. So, there's an awful lot more to do to tell you about, but let me set you off. Another thing to mention is that if you go on YouTube, you will find, and the beauty of YouTube is there are a lot of university lectures are put on the internet these days, and a lot of them are absolutely brilliant. So you can actually do a geology degree sitting there in lockdown with nothing better to do. And I've spent countless hours, as I say, talking to a wonderful professor, Nick Zentner, from Central Washington University, talking about Washington State. I know more about Washington State than I do about Shropshire now. But I just this afternoon watched a video about the Mendip Hills, very fascinating. And in fact, I met the Frome limestone that this gentleman, Mr. Connor, was talking about just now, the Frome limestone, presumably Frome in Somerset. Which is...
No, it's Herefordshire.
Oh, there's another Frome, is it? But there are Silurian rocks in the Mendip, so I thought it might be there. I don't know. But, I exhort you to go on the internet and look at YouTubes for geology, and you'll just get absolutely fascinated. But best of all, you know, get your snorkel and your go back in your mind into these deep seas and look at the fossils and the rocks, and you learn. You know, I'm learning every day. So, and it's obsessed me since I was 6 years old. But when you go to a girls' school in the 60s and you want to do geology, they say, "Oh, girls don't do geology." So I made the huge mistake of becoming a doctor, a medical doctor, which really, you know, anyone can be a doctor. But now I'm actually found my vocation, and it's geology and always will be. And I just wish to goodness I could go back to being 15 and insisting on doing geography A level instead of math, physics and chemistry. So there we go. But it's a subject any amateur can get into and is accessible. And it's so important. Everything depends on our geology, the soils, you know, our industries, our everything.
Ali, I think we've got, sorry to interrupt you, we've got a question from Mike and Zia, I think.
Oh, right, yes, I thought they'd gone, right?
I'm still here. Sorry, now. Yeah, I really wanted to thank you. A fantastic talk. I just want, was gold laid down at the same time as lead, and you do the area with lead and stuff? It's gold at the same time. Was that pulled up from another era?
Well, gold is only it's a sort of around volcanoes. So the Welsh gold is sort of produced around volcanic aureoles, as we call it. But yes, essentially, it's another element that's come from hydrothermic, what we call hydrothermic intrusions. So yes, essentially.
I know it's in Slanamunnock.
As far as I know, we haven't got any gold in Shropshire, but certainly, I mean, as soon as we can escape, we'll go off to our flat. We've got a flat in Barmouth, and I've got a very, very detailed geology text, which is the Field Studies Council of that part of Wales, and they're about to reopen the gold mines at Cloggy because they've found another rich vein, and those are all quite near a volcano called the Robel Fawr, which was the first Ordovician volcano in North Wales, which is just near Dolgelly. And that's responsible for a lot of these hydrothermal fluids that form the gold. So I shall be off looking for gold.
I thought there was gold on the border at Slanamunnock. I thought they'd found the Romans found some there. No?
No, not as far as I know. No, never heard of it. Copper, lots of copper in Slanamunnock Hill.
Yeah, maybe I confused with that, but I thought there was a little bit of gold found somewhere there.
No, I don't think so, Zed, as far as I know. But you never know. How about you give up horses and take up gold panning? I'm sure if anyone can find gold, it will be used here.
Thank you for a fascinating talk.
Well, I'm glad you enjoyed it. It's hard to gauge when you can't see people's faces, but it's probably an advantage that I can't hear the snoring either. So there we are. How many people are still on?
Are there any more questions from anybody who?
Any more burning questions? I probably can't answer.
What time can we go now?
Love to do a glacial safari. That's going to be difficult. The glaciers have gone, but I see what you mean, yes. We'll take all these questions, won't we, Connor, and digest them and think about the future. But I'm very happy to carry on and enthuse people if I can, because it's just such a wonderful, life-affirming. And what I particularly like is it puts us in our place. You know, all these poor people rushing around worrying about global warming and mass extinctions and so forth. And well, you know, it just happens all the time in geology. No one bothers, you know, it puts us in our place. We're pretty irrelevant, really. We just crawl across this earth for 70 and a bit more, luckily. Oh, yes, it stays in place. It doesn't move like, you know, my daughter's an ornithologist and you have to kind of catch the birds when you can. But rocks just sit there. They're very much more convenient. But anyway, that's it, Rock. I think it's time for bed now.
Well, Sally, thank you ever so much for this talk.
All right.
It's obviously turned out to be very popular.
Well, that's nice. Yes, thank you. People are
As you
just
say, everybody will receive a follow-up email as well.
Yeah.
So thank you so much, and thank you everybody for joining us.
Yeah, thank you everybody for coming.
Yes,
Good night. Thank you.
Thank you. Thank you.
Good night, everyone.
Good night. Right.
Thank you, Connor.
I might just have to smash this screen with my hammer.
Just a few more to go. Give it a moment. We still got a few more people.